So as discussed earlier, instance methods or instance fields can be accessed after instantiation. Now this time for static method, it is defined with the static keyword. If we look at our example here, previously, the method compute grade is non-static or called instance method. But if we're going to make this static, all we have to do is to put that keyword static in here. This keyword static makes this method compute grade this time a static method because it has the static keyword. Now that this is a static method, what happens to this method? This time that compute grade is now a static method, it can be invoked without instantiations. Okay, so take note, it can now be accessed or invoked without instantiation. Unlike when it was previously an instance method, because it has no static keyword, it can be accessed only after the instantiation of the class. But now that it is a static method, it can be accessed without instantiation. And it's convenient to define utility methods such as calculation methods as static so that you can directly call or access them without instantiation. Next is, in order to invoke static methods, how do you call or access them? You call them or access them using this syntax. So first specify the class name, and then the dot operator, and then the method name. So this is the syntax to access or to call or to access a static method. It is accessed or called via or using the class name. Unlike when it is a non-static method, how do you call it? It is called using the instance, right? Recall the syntax to calling or accessing a non-static method. It is via the instance and then that and then the method name, right? Just like how we called the method in here, compute grade. Okay, it's via the instance. S2 is an instance. Earlier, we defined compute grade as non-static. Therefore, we can access compute grade only, or we can call compute grade only via the instance. That's why we need to instantiate the class. After instantiation, we create the instance, then we could access or call the non-static or the instance method via the instance. But when we are going to save this, so that this method now, compute grade, is a static method, so there is an error here for grade. We cannot make a static reference to non-static field grade. Okay, so we can remove this for a while so that we will get rid of that error. Then let's save this and let's go to the caller class. So what happens to the compute grade now? We have here a warning sign, a warning mark. The yellow mark here is a warning, okay, or it is something like an error. So the warning is the static method compute grade. Take note that compute grade this time is now a static method. And it should be accessed. It says here that it should be accessed in a static way. How do you access a static method in the static way? By using this syntax. Okay, so it should be class name this time, not instance. So going back here, okay, take note we have here a warning or a possible error. If we change this to class name, what is the class name? It is student, right? So if we change S2 to student, the class name, take note that the warning or error message disappears. And in here also, we have an error, static method. Okay, let's save this one first. Okay, so we have no error anymore. And then we have here another one. The same, the compute grade method is now static. Therefore, the right way to access or to call this is via the class name, not via the instance. Okay, so we change this to class name, which is student. Okay, so we get rid of the error. So once again, how do you access or call a static method? It is via the class name, not the instance. If compute grade is a non-static or an instance method, you would access this or call this via the instance, which is S2 or S. For the static fields are defined with the static modifier, just like the static methods. And static fields are also called class variables or class fields. And they can manipulate values without instantiation. So just like static method, either it's a static field or a static method are accessed or called without instantiation. So again, instantiation is necessary only if the field or the method is non-static. Okay? So if it is non-static field or method, or also called instance field or method, if the field or method is non-static or instance, then you need to instantiate the class so that you create instance variables, and via that instance you access the field and the method because they are non-static or instance fields or methods. But for static field and static method, they can be called or accessed without instantiation because these are accessed or called via the class name. So how are they called? You say class name, indicate the class name, dot, and then the field or class name dot method. So again, static field or static method are accessed via the class name, while non-static field or method or instance field or method are accessed via the instance. You would say instance dot field or instance dot method. Okay, this is for non-static or instance field. Now, what is the purpose for declaring static fields? The answer to that is this one. The purpose of declaring a static field is so that you will declare common values to all instances of the class. Okay, because they are called class variables. Static fields value is common or same for all instances. They are also called constants because they have common or same value for all instances. In order to use a static field of another class, you would access or call them this way, using the class name instead of the instance. We have here the syntax to declaring a static method and static field. So if it is a method, you just put that keyword or modifier static before the return value. If it is a field, then you put the static modifier or keyword before the data type of the field. And the way to access these static fields or methods is this one. First, for the method, it would be via the class name, the dot operator, and then the method call. And if it is a field, then again, class name, dot, and then the field name. If these are non-static, you would change this class name to instance, right? But for static field and method, you would use the class name and not the instance. Just like in our example here, this is a static field. We have this static modifier or keyword placed before the data type of the static field, school name for student. And for the static method, we also put that static modifier or keyword before the returned value of the method. In this example, sample is the color class and calc is the cold class. And in the cold class, we defined two static methods. The first one is plus. Okay, it is a static method because we have here the static modifier, and also minus is a static method because we have the modifier static. And so in the caller class, how do we call these static methods? We call them using the class name calc. Okay, that is the class name. Also, minus is called using the class name calc. And the reason for that is these two methods, plus and minus, are static methods. That's why they are called using the class name. And so notice that since these two methods we called or access are static methods, there is no instantiation in the caller class. And remember that there is no need to instantiate the called class in the caller class because the methods that we are trying to access or call, the plus and minus methods, are static methods and they are accessed only using the class name and not via the instance. So that when we display the values of ans1 and ans2, we have a value 9 for ans1 because ans1 is set to the value returned by calc.plus, and in this case 5 plus 4 is 9, and for ans2 the value returned is negative 3 because 3 minus 6 is negative 3. For the characteristics of static methods or static fields, first, static methods or static fields should be used without instantiation. Second is they are allocated to classes, not to the instances. That is why they are called class variables, the static fields or class fields, and the static methods are called class methods, not instance methods. And third is it can hold common values. That's why they remain in the class. So as you can see here in the figure, we have here class calculation. That is the class name. The static field is circle ratio. Okay, this is a static field, while these two are static methods. And take note that these static fields and static methods, circle ratio calculation, and absolute value calculation, they are not allocated to instances. If this is instance C1, C2, and C3, all of these three, C1, C2, C3, are instances of class calculation. Now, since static fields or class variables can be used without instantiation, it cannot be initialized using a constructor because a constructor is called only during instantiation. And so for static fields, we use static initializer. So this initializes static fields, while non-static fields, or those we call instance fields, they are initialized using a constructor. So again, static fields are initialized using static initializer, while non-static fields or instance fields are initialized using a constructor. And it is executed only once when the class is initially used or when the class is first accessed or used. For simple initialization, the static initializer does not always have to be used. So you may not use a static initializer to initialize static fields. Although the formal way, okay, so the formal way to initialize static fields is by using static initializer. This is the syntax of a static initializer. So it starts with the keyword static and followed by the block or the scope of the static initializer, which is marked by the open curly and the close curly. So inside the curly braces, we have here the processes that are needed for initializing the class variables. We could write in here the initializations. We could write in here the setting of initial values to the static fields. Now we have here an example. We have in here even as a static field, and it is even is a one-dimensional array of integers, and we use static initializer to set initial values to the 1D array even. First, by allocating RAM space. So remember, this part here is the first part of array declaration. Okay, remember what is involved in the first part of array declaration? Declaring the array name, which is even, and declaring that it is a one-dimensional array because there is only one square bracket, and the data type of the array elements. And in here, inside the static initializer, we have the second part of array declaration. And the second part of array declaration involves specifying the size of the 1D arrays. So the 1D array has 30 elements, and these 30 elements are all integers. And also, at this point, the array is allocated memory spaces or RAM spaces. After the memory allocation, then we set initial values using a for loop. Okay, using a for loop, we initialize the 30 elements of the 1D array. So first iteration is when I is 0, so this set the value of even 0. Second iteration, we increment I, so second iteration, this is now even 1. We set it to another value. Okay, so even 0 is 0 times 2, this is 0. Even 1 is 1 times 2, this is 2. Even 2 on the third iteration is now 2 times 2, this is 4, and so on up to the last, which is even. What is the last value of the index? It is 29, right? Because the condition is I less than 30. So the last value of I is 29. That is the last index. Okay. And so the last array element is even 29, and that is equal to 29 times 2. That gives you 58, right? So this is how the static field, a 1D array even, is initialized using a static initializer. Now, if we are not using a static initializer to initialize the 1D array even, then the only way to do that is by direct initialization, which is very tedious or difficult because you have 30 elements to initialize. That means you are going to list in here, list all the 30 initial values. And that is tedious. Now, what if even has 100 elements or 200 elements? That would require you to list 100 initial values or 200 initial values. That is very tedious and that is not efficient. It is not an efficient way to initialize 100 elements. So the efficient way is by using a static initializer, because using static initializer, you could write a code just like this for loop in here. Okay, you just extend this to say 100. From 0 to 99, that's 100 elements. You are initializing for 100 elements, and it takes only a very short code, which is a for loop, rather than doing it this way where you are required to list all the elements. So again, this is not the efficient way to initialize the static field, but the efficient way is by using a static initializer. Now that we defined one static field, which is school name, okay, this is a static field because of that modifier static, and this is compute grade is also a static method. Now that we have defined a static field school name and static method compute grade, let's try to check in the caller class how we're going to access this static field and method. So if we try to access the static field school name via the instance, we would say s dot. Okay, let's try to check if we have here in the list the school name. Yes, we have it here. If we are going to check that, and then say we set that to USTP, what do we get here? We get here an error or a warning message saying the static field student that school name should be accessed in a static way, not in a non-static way. It should be accessed in a static way. And what is the static way to access static field? It is by using the class names. So we would say student instead of S. And take note that the warning or the error message disappears once we access the static field school name via the class name and not via the instance. Say we try to output the school name. So we say school of S student, student 1, say S dot school name. Okay, we have here a warning message again saying that the static field school name should be accessed in a static way. The static way is to use class name instead of the instance S. But let's just leave it that way and say we also output the school of student 2, which is S2. Okay, so we have two students, S Juan de la Cruz and S2 is Maria Clara. Okay, so just to check if they have the same values, if student S Juan de la Cruz, Juan Cruz, and the second student S2 Maria Clara, if they have the same school name. Okay, so let's run this program. And what is the output? Okay, both students, Juan de la Cruz and Maria Clara, have the same school, USTP. Okay, so remember that static fields have the same value for all instances. Okay, that's why they are called class variables, because this static field has a common value for all instances of the class. If we change this to, say, UP Diliman, okay, run this one, what happens to the school name of the instances? For student 1, it's UP Diliman. For student 2, it is UP Diliman. Okay? So again, the static field is a class variable and it has a common value or the same value for all instances of the class. But static fields are not constants, right? Because their values may change. Say, for example, in here, we could set this to USTP at first, okay? And then when we go here, say, we put the modification here. So what is the output in here? Okay, let's try to find out later. So copy this one. Okay, just to compare if the output here should be USTP and the output here should be UP Diliman. Okay, because we change it here. Okay, so let's try to run this. Okay, so the output is USTP first, and then we change it to UP Diliman, and then when we output again, the school is now changed to UP Diliman for all students. So again, a static field is a class field. It has common or same value for all instances of the class, but it is not a constant because the value may be changed at any point in the program, just like what we have in here in the example. Now the question is, how do you decide if you're going to declare a field as a static field and if you're going to declare some fields to be non-static or instance fields? Now this is how you will decide. You declare a field like school name as a static field if it should be assigned a common or same value for all instances of the class. Like for example, all students, S1, S2, S3, all students has the same school name because this Java program is for student assessment of USTP. So the school name of all the students should be the same. And if it is the same value school name for all students, then that field school name should be declared as a static field. But for these fields, ID of the student, name of the student, course section, year level, and grade of the student, these fields have different values among different students of USTP. Therefore, these fields should be declared as non-static or instance fields because they are intended to have values that are different among students, while school name should have a value that is the same for all students, and therefore school name should be declared as a static field.